Hey everyone, here are the guided notes for 8.6. So big idea here, if a person invests $100 in a bank with 6% simple interest, which we learned about yesterday, they earn $6 in the first year and 6 again in the second year, totaling 112. If this was really how interest operated with most banks, then someone clever might think to withdraw the 106 and immediately reinvest it, and that way they earn interest on their interest. At the end of the second year, they would do it again, and they would make an extra 36 cents. Now that doesn't seem like that much, but over a course of many, many years, that could be quite a bit of money. So if we talk about it, how much more would a person earn if they saved their $100 for 50 years at 6% compound interest, which is what we were just talking about if you took it out and put it back in each year, rather than just the 6% simple interest? Well, that's what we're going to try to solve. So compound interest allows interest to grow on interest. And that is the best kind of interest because essentially you are making money on money that you did not put in. So the formula for finding compound interest is a little bit tricky. So I'm actually going to try to write it here if I can. It is, here, I'll put it down here. And then I'll move it into that box. All right, so T is equal to P outside of 1 plus R divided by N, all raised to N times T. Now this is a lot. I know, this is crazy. I threw a lot of variables at you. Take a minute. T, actually I'm going to put it over here. T is the total amount of money at the end. So when we're ready to take our money out, that's how much money we're going to have. P is still the principal interest. Still the principal amount that we invested. R is still the rate. T is still the time that it's invested. The only new thing we've added is N, which is the number of times that we are given interest. Number of times interest is paid. And this is always once per year in the case of what we're working on today. So once per year. I know this went outside of my box, but maybe we can just move it up a little bit. Yeah, there's your big idea. I know that's hard to see, but how does this work then? Well, how much will Kyle have in a savings account if he saves $3,000 at 4% compound interest for 10 years? Well, let's write down what we know. Our principal amount is $3,000. That is how much he invested. We know our rate is going to be 4% or 0.4 because as I talked about in the simple interest video, we can't talk about percents without using decimals. The time is going to be 10 years. And then N is going to be the number of times interest is paid. And because it doesn't tell me anything, I'm going to assume that it's 1 time per year. So now, if I want to fill this out, I'm actually going to go into my math type so that you can see this. You can see how I'm plugging things that'll look a little bit better. So T, the amount we want, is equal to P. What was our principal amount? Well, if we wrote it down, we know that it was $3,000 times 1 plus R over N. What was our rate? It was 0.04. Our number of times interest was paid out was 1. And then we raised those parentheses to the N times the number of years. So that's 10. So this is what we end up getting. This is our formula. Now in order to solve this, we need to take it in chunks. So we're going to simplify our parentheses first. 0.04 divided by 1 is just 0.04. 1 plus 0.04 is just 1.04. We're now going to raise that, remember exponent before multiplication, so raise 1.04 to the 10th. We get 1.48, really long decimal, and then we multiply that times 3,000. So when I do this, I end up getting a total amount, the amount I want in the account, to be $4,440.73. And it's all plugging in just like it was for simple interest. So let's see that again. Let's see another instance of this. Before I was looking for T, which was the total amount in the account. This time it says what interest rate is needed. So we are looking for the rate, not the T. It says I want to grow $100, aka a principal amount of 100, to a total of $120. And I want to do it in little t, time of 3 years. And as we did before, we're just going to assume that that n is once per year. So we're looking for our rate in this case. Again, I'm going to open up that math type so we can see what I'm plugging in. So the t we said was 120. We set it equal to 100 times 1 plus r over n. We don't know what our r is. We know that our n is 1. And we know it's raised to the 1 times 3. Now, why is this equation tricky? Well, instead of just being able to plug and chug here, we actually have to solve this. We have to solve it for r specifically. So I'm going to do that by just trying to get r alone. And the first thing I'm going to do is I'm going to simplify my parentheses. I know that inside the parentheses, I'm going to have 1 plus r, because r divided by 1 is just 1. So 1 plus r in parentheses, and it's going to be raised to the third, because I can simplify this. Now I want to get that 100 away, so I'm going to divide both sides by 100 in order to get the parentheses by themselves. Let me show you what that looks like in my equation. In case you're wondering why I'm not doing this on my normal paper, it's because my computer is broken and I cannot use my dot cam right now, but I will get back to that as soon as I can. So when I solve this, I get a 12 over 10. I could simplify that to 6 over 5 if I wanted to, but I get 1 plus r to the third. Now, how do I get this away? How do I undo that cubed? So I need to take the cubed root of all of that, but whatever I do to one side, I must do to the other. So I'm going to take the cubed root of both sides. When I do that, I'm going to plug that into my calculator, say the cubed root of 12 over 10. You can also do this on a computer. You will end up getting 1 plus r on your right side. And when I throw this in, give me just a minute to do that, I will get 12 over 10, 1.06 on my left side. Now to solve for r, all I have to do is subtract that 1 away, and I end up getting r equals 0.06. When we turn that into a rate by moving the decimal place, we find that we would need a 6% rate in order to make that $120. This one was a lot more work than that first one. That is okay. I will not ask you to do one of these on the test. These are a little bit trickier, but I wanted to show you that it can be done if we want to. All right, last example. How long will it take money to double if it is in an account earning 8% compound interest? We would do this one the exact same way that we did this one. So I'll set it up right now. If I invest $100, the doubled amount is going to be $200. So the total amount I'm going to put as 2. 100 and 200 just amounts. I could invest $1 and get $2 out as well. But I'm going to show you by doing this. So 2 equals 1, and then 1 plus r over n, still just a 1. So we got 1 plus r in there. And then 1 times 1, because we're only investing it for, 1 times t. Excuse me. I made a mistake there. We know that it makes 8% as a rate. So inside here we actually have 1.8, 1 to the t. Now, I could, in theory, solve this for t. It would not be easy. So, I have a better option. I have something called the rule of 72. So, if you look here, the last problem I did can be solved, or we can use a shortcut known as the rule of 72. I'm going to talk about that in the next video, so go over and check that one out. I don't want to do this because I am running out of time on this video. So 8.7 will be in the next video.